Hi, my name is Dan Harmon. I'm the Business Development Manager for Texas Instruments Sensing product line. I'm here today to demonstrate TI's new 3D time-of-flight gesture technology. The 3D gesture solution from Texas Instruments starts with an LED or laser driver, which drives an infrared LED or laser, which emits energy, which is reflected off the object that you are trying to measure or trying to track. That energy is then received by the 3D time-of-flight pixel, depth sense pixel technology sensor, which interprets the time it took for the infrared energy to travel to the object and back and converts that to a depth or a distance. That image output is then processed by the analog front end, which digitizes it and converts it into the time-of-flight controller. The time-of-flight controller takes that raw pixel depth image and creates what we call a 3D cloud, which is used by the application layer or the middleware to interpret the gesture or to interpret the object. In addition, TI has a wide selection of power management devices which can be used to analyze this technology as well. In the demonstration setup, what I have is a DS325 camera from our partner that is a company called Softkinetic. They also provide the evaluation software we have here that does some basic gesture recognition and basic demonstration. So to start with, let me just show the basic idea here. You can see here with my hand, the pixel technology is enabling the 3D time-of-flight as tracking my fingertips as indicated by the spots on the end of them. It's also tracking which way my fingers are pointing as well as which way my palm is pointing. Let me turn on one function here just for a second. It's called the centroid function. So the centroid function is actually where you can see the 3D cloud that is the surface area of my hand. So the software is monitoring each one of those points to determine where my hand is in space and time. I'm going to turn the centroids back off here. And now I want to kind of talk about some of the benefits of the 3D time-of-flight technology versus some of the competing technologies. You can see this is a very real-time technology where it's tracking my hand no matter how I move it in real time. You can see that it also tracks the fingertips very well. And this is a benefit of time-of-flight over something like structured light, a competing technology called structured light, in that the responsiveness or the timeliness of the technology is much faster than structured light. In addition, TI's depth sense pixel technology does a lot of the pixel processing in pixel, which enables it to free up the back end for gesture recognition as opposed to pixel processing, which enables an overall lower system bill of material cost. You can see in the bottom right-hand screen the actual depth map itself. So as I get closer, I get darker. As I get farther away, I get lighter. So this is actually the measurement of what's coming out of the pixel sensor itself in terms of the depth. One of the other benefits of this technology is you can see it's capable of tracking two hands at one time. It can interpret basic gestures such as peace sign, closed fist, open hand, 4 fingers, 3 fingers. So these are all ways in which the technology is interpreting what's coming out of the 3D cloud. And so this is all what you can use then to build real-world applications. So now what I want to do is I want to actually demonstrate a couple applications that can show how this might be able to be used in an actual application. And so the first one, what I want to talk about is the ability to manipulate an object in 3D space, whether that's rotation, expansion, compression, or tilt of the object. So you can see here I have this demo software up and running. I'm able to, with movement in my hands, I create the solar system. I can tilt the solar system side to side just by moving my hands. I can rotate it so that I can get different views of it. I can make it smaller, I can compress it, I can expand it and make it larger. And so this is a really good example of how you could use this technology when you want to do inspection or evaluation of an object before you actually commit to hardware prototyping. The next demo that I want to run is to show the ability to basically do fine tracking, fine gesture control of the fingertips. And so this is a way where you would use this for basically for mouse replacement. But in addition to just 2D, this actually understands depth, and therefore it's ideal for control in a 3D environment. So this is a little demo software again provided that you can see as I closed my fingers, it showed me grabbing the ballista and pulling it back. As I move my hand up and down, side to side, you can see that the track is going. When I open my fingers, it actually releases the weapon. It wasn't a very good shot, obviously. And so this is an example of how you could use this software to be able to manipulate objects in place of a mouse. In summary, TI's 3D time-of-flight solutions, enabled by DepthSense pixel technology, offers improved IR sensitivity, more reliable gesture recognition, higher frame rates, lower post-sensor computational requirements, and is less expensive and faster to design into your solutions. For more information, please go to ti.com/3dtof. Thank you for watching.